Hi, Professor. This is Haider Hussain bearing CWID 50308833. I hope you are doing good. I'm doing this presentation for my final project in database subject. So, as a part of my final project, I have selected electricity billing management system database. In this project, um, I created a database using MySQL application, and I have inserted data and manipulated data using multiple queries. Coming to the abstraction of this project, so what is electricity bill management system? So this project is a simple backend application developed using MySQL Workbench application. It manages the records of customers' electricity bills. The admin can manage all the customer accounts and register users like employees and customers can only manage their accounts. The system helps to maintain the bills and the payments. The database of electricity billing system is organized in 9 tables. So we have 9 tables in this database. These tables are namely admin, customer, account, billing, invoice, electricity board, tariff, and feedback. So the admin is the in charge. He has multiple accounts and he can access all the customers and account billing information, including the tariff and feedback data as well. So these databases are designed by considering basic needs encountered at the time of bill generation or distribution or payment of the electricity bills. So coming to the MySQL Workbench, which I have used to design this database, it is a tool which we can use to create a database in a simple way. It provides visual interface for creating and editing and managing the databases, and we can easily create and play around with the tables, columns, and data, and we can create the indexes around the tables using this MySQL application. The performance is really good, and it also includes tools like database migration and reverse engineering of existing databases. And it's also available in Windows and Mac OS. So the purpose. So what is the purpose of creating this database? Electricity management billing. So electricity bill management system is designed to provide an automated and centralized system to manage the bill payment and consumption of electricity in a particular region. It allows users to efficiently manage their bills, track consumption, and generate monthly reports. The system also enables customers to pay their bills online, set up automated payments, and receive notifications of upcoming bills. So this system really helps us to do our things in a easy way, and also ensure that the electricity bills are processed accurately and timely, and helps to reduce the cost and improve customer satisfaction as well. Coming to the importance. So importance of electricity bill management system in our day-to-day lives. So the electricity bill system is important tool for business to utilize in order to keep track of their electricity usage and bills. The system allows business to monitor the electricity usage, analyze their bills, and take corrective action to reduce their cost. This system is also used to create reports and track progress, allowing business to set goals and track their progress in achieving them. Finally, it can help business make informed take strategic decisions about their electricity usage and help them to save money in long run. So what are the open scenarios we have for this electricity bill management system? So generating a bill, that's one of the basic service that has to be provided by this application. So the electricity bill management system enables the admin to generate bills for the electricity consumed by the customers as per their usage. So the system also allows for the consumption of bills as per customer preferences. So the customer can can customize like when he want to pay these bills every month. Payment processing. This system also allows payment processing of bills through electricity, through digitally, by going to the office, and it allows customers to pay their bills through multiple payment options such as online, offline payment gateways, card, debit card, credit card, and more. So billing history. This system also keeps track of billing history of customers and provides an easy way to access their previous bills. This helps the customers to stay updated on their billing information and allow them to review their usage. Coming to the reports and analytics, the system allows also helps to generate reports and analytics to help the user gain insights on customer usage patterns. It also helps to understand customer behavior and target their marketing strategies accordingly. Customer support. This application also provide customer support to the customers in case any queries or any issues the customers are facing, and it has a contact number or customer support number that we can contact via phone or email, and get our issues resolved as soon as possible or in a timely manner. Coming to the schema of this electricity billing system, this schema has 9 tables, as I said before. So admin is the mm, admin is the one who handles all the tables. He has the access to customers and accounts and invoice and feedback tariff, all the information. And coming to the account has accounts like the employees who are working within that electricity billing company. So they have a specific account with the ID, uh, and a customer number and a board ID, account name, address, and everything. Coming to the customers are the end users of this application who also has a customer ID, customer name, account name, address, state, pin code, email, all the regional address, geographical address of a customer is stored in these tables. Coming to the billing. So billing is the electricity charge that has to be paid by the customer since he has utilized the electricity for a month. So for every bill, there is a unique bill number and the associated customer ID, so that we can extract the customer name from there, and also the payment mode, how he wants to or how he had did the payment, and also the payment date, payment time, and also the amount he paid, and also the excess amount if he had paid any excess amount, and also the status whether is a active, whether it's paid or unpaid. Coming to the feedback, so once the customer pays the bills or he has any issues, there is a table called feedback where he can store or save his feedback so that the admin can look into it and resolve the issues if he has any. So for every feedback, we have a unique feedback ID, and also the customer ID is associated to this table, so that which customer had this issue so can be tracked back. And also we have a text format of a field where the customer can mention the comments related to related to the feedback and also the status. And coming to the invoice is something once the customer paid the bill, the invoice is like a receipt that he gets as a response, as a acknowledgement to him. So invoice has a unique ID, invoice ID, and it also connects with the electricity board table, account table, and all the tariff information. What was the reading? What is the present reading? What was the previous reading? What is the charge, electricity charge, and the tax that we applied on that bill, and the consumption, all this data is available in invoice. Electricity board. So every customer who has a electricity meter, that data gets stored into the electricity board. So every electricity device has a ID, and also the logo from which company it's getting accessed, and also some status like whether it's a active electricity board or not. So coming to the ER diagram of electricity management system, as in this diagram, I have explained all the relations between the tables and also how the flow and control moves from one table to another table. So the admin creates the electricity board, admin adds the tariff to this tariff, adds data to the tariff table, and the tariff table depends on invoice. And so there is a customer, and customer can able to publish his feedback use in the feedback table, and customer can also add a account which is a new account or an existing account. He can do some manipulations on it, and he can pay the bills through the account, and every bill has a bill number, payment date, and payment time. When he paid the bill, it generates an invoice, and invoice has the invoice ID, bill number, and tax, all the informations. And it come it so it depends on the tariff, and the tariff goes to the admin as well. So this is about the schema of this database. So content. So these two files has uh, creation and insertion queries related to this database, and these are the queries that I have performed on this table to play around with the data, to perform all the logical and logical and operational queries on this database. So I have used select, delete, all the comparing operations, and also some um, combining operations like join and inner join, upper join, everything. So let's run each query and see how it behaves on in the database. So this is the database I have created, and it has all the tables here. Let's run this query and see how this database behaves. Select billing. So once I click on that, so it opens a billing table, and it has all the data in it, as you can see. The same thing for customer. So it should select star customers should show all the customers available in the table. As you can see, the customer ID, customer name, account type, address, state, city, pin code, email address, password, and status are present in this database and in this table. So this query helps us to understand which uh, admin is active, and it pulls the admin ID, admin name, login ID, and the type information of the admins. So if we see here, so only the active admins are getting fetched. Out of 7 admins, only 3 admins are active. That's why we could see only 3 records here. Coming to select customer ID. So in this customer table, we are fetching the data, customer ID, customer name, and account type by looking for a specific customer 1005. So once we give that run that query, so we could see the details of the customer 1005. Coming to some operation I have performed in this query, where it sums the amount of a specific customer, like how much he paid in total for a electricity bill. So the total amount paid by 1005 customer is $1317, which helps him to analyze the report or track his billing information. Coming to this query is performed on billing table where we are looking for customer ID, billing number, bill amount, payment date, and payment time. And the payment, so all the payments that were done before this date, after this date should be populated. So as you can see, this so and so customer has done this many transactions after this specific date. Let's see what this query will do. So this query is related to billing table. And here we are joining the tables, and after joining the tables, we are trying to fetch the data in both from both tables by using a where class. So I'm trying to fetch the customer name, bill amount from customer, from billing, and also the customer for a specific patient called 1005. So yes, so this is the customer and this is the billing amount of that specific customer. So admin can just run this query and can see how many times and how much money was paid by this so and so customer. This query is to check the bill amount, which is more than $220 from the billing. So if the admin wants to check how many customers has paid more than $220, he can run this query and can see how the list of customers who has paid more than $220. So coming to this query, here the customer, we are performing this query on both billing and the customer tables. And we have used a join, and we have joined this two tables using the customer ID. And also we have joined three tables here. There is one more table which is invoice, and by joining all these tables, we are trying to fetch the information or fetch the columns or fields for a specific customer ID 1005. Since okay, so since this customer has no data in the invoice, we don't see any data here. That's expected. Coming to this one. Okay, in this query, we are performing on electricity board table where we are looking for a specific electricity board ID and the account number and the ID related to that board. So as you can see, this is the account number and this is the electricity board ID. So from this account number, we can trace back to the customer who is using this board. So in this query, we are trying to look for patients look for the customers who are inactive by using the invoice. So we have two records here. These accounts and these are the electricity boards which are inactive, and this is the bill numbers of those account holders. Coming to this query was performed on billing table where we are looking for the billing amount greater than $100, and the billing amount should be in a descending order. That's why we have given the billing in the query like order by bill amount DSC, and it will fetch the customer ID, bill number, bill amount, and paid amount. Yes, so as you can see, the highest amount is populated on the top of the record, and the least one is at the end of the record because we have given the DESC operator within the query. So so here in this one, we are trying to in this query, we are trying to uh, see the present reading, which is greater than 1233 from the invoice. and it fetches the account number, bill number, and consumption units for a specific invoice, which has the presenter reading as a specific number 1233. So, and this drop table will drop the table, and this table, this query, update the existing customer's name into Ravi from customer 5. So these are a list of queries that I have performed. There are few more queries that I have performed. Due to time constraint, I'm not going to execute those, but I have added that into the table in my document. So by use in these queries, what are the relationships I have used, and what are the relationship I have used, and also that what is the connection between the tables is I have mentioned here. So mainly in this database, I have used one-to-one, many-to-many, and one-to-many relations. So what is one-to-one? So it shows the relation between two tables in a database where each row in a table is linked to only one row in a table in other table. So coming to one-to-many, it shows relationship between two tables in a database where one record in the first table can be related to multiple records in second table. So for example, a customer table may have one-to-many relation with another table, with orders table. It means that each customer can have multiple orders, but each order can only belong to one customer. Coming to many, so it shows the relation between two entities in which entity can have multiple instances of the other entity. It has also used a primary key, which is used for joining. So the primary key constraint is a column or a group of columns that uniquely identifies every row in the table of the relational database, and it can't be duplicate, meaning the same value should not be appear more than once in the table. It is used to ensure data integrity and prevent duplicate records from being entered into the table. A table can have multiple primary keys, and primary key can be defined at the column or the at the table level. So I have also used the foreign key. So foreign key is a field in a relational table that matches the primary column of another table. So it's a column that creates relation between two tables. The purpose of this foreign key is to maintain data integrity and also allow a navigation between two different instances of the entity. So this is the referential integrities that I have used. So referential integrities constraints are used to ensure that data in the database is consistent and accurate, and they are used to maintain relationship between two tables by ensuring that any foreign key values in one table must also exist in another table. So this is set when null. So this is one of the constraints integrities that we have used. So set null, if a user tries to delete a statement that will affect row in a foreign key in a table, those values will be set to null when the primary key record is deleted in the primary key table. And cascade. So if a user tries to delete a statement which will affect the rows in a foreign key table, then those rows will also deleted when the primary key record is deleted. So yes, this is all about my presentation. Thanks for your time, Professor. Have a good day.